Assalamualaikum warahmatullahi wabarakatuh. Okay, so this is the lecture video for our syllabus in week 5. Okay, week 5. In week 5, we are discussing two subtopics. The first one is about the chain rule, and the second one is the derivation of trigo function, exponential function, and log function. Okay, so we are covering two subtopics for this week. Okay, the first subtopic is about chain rule. Okay, in this topic, we will discuss the derivative of composite function. Okay, composite function. So, each of the composite function, we will differentiate them using chain rule. Okay, for example, we already know how to differentiate x cubed and x squared minus 5x. Okay, we already know how to differentiate these two functions. Okay, x cubed, when we differentiate it, we will get 3x squared, and x squared minus 5x, when we differentiate this function, we will get 2x minus 5. Okay, so you already know this one. So, but how to differentiate this function? Okay, the same function, x squared minus 5x, but we got power of 3 here. Okay, so to differentiate this function, we will take a look at this example. Okay, the same function as I mentioned before, which is x squared minus 5x power of 3. So we want to differentiate it, meaning that we want to find what is our dy over dx. Okay, so there is two ways to differentiate this function. The longer way is you need to expand the power of 3. Okay, meaning that x squared minus 5x multiply with x squared minus 5x and multiply with x squared minus 5x 3 times, and then we will get these terms. Okay, x power of 6 minus 15 x power of 5 plus 75 power of x power of 4 minus 125 x power of 3. Okay, and then when we differentiate this function, we'll get 6x power of 5 minus 75 x power of 4 plus 300 x power of 3, and then minus with 375 x power of 2. Okay, this is the longer way where we need to expand this function 3 times. Okay, multiply 3 times. So our working solution will be a bit longer compared to the second way to differentiate this function is using chain rule. Okay, so how to conduct chain rule? So from this original function, okay, we need to assume our u. Okay, pilih apa-apa u. Okay, actually u is the simplest form. Okay, the simplest form. To choose your assumption u, you need to choose the simplest form. Let's say for this function, x squared minus 5x power of 3, so you need to choose the simplest form, which is in the bracket. Okay, in the bracket. Okay, you all tak boleh pilih x square only. Okay, x square saja tak boleh sebab x square is dia ada kawan dengan negative 5x. So we need to choose the whole two terms here as our u. Okay, so our assumption u is x squared minus 5x. Okay, so if we let these two terms as u, now the function will become y equals u power of 3. Okay, because our u is in the bracket, so we got y equals u power of 3. Okay, so y equal to u power of 3 is the easier form to u for you to differentiate. Okay, because u power of 3, you know, when you differentiate, we will get 3u power of 2, right? Okay, so this is the simplest form when we assume our u is equals x squared minus 5x. So this function will become y equal to u power of 3. So this is easier for you to differentiate. Okay, so this is our aim to, when we perform chain rule, okay, we want to change this function into the simplest form, okay, into the simplest form. Only after that we can differentiate it easily. Okay, now what are we going to do next? Okay, so from this assumption, from the original function, okay, which is y equal to x squared minus 5x power of 3. So when we assume u as this function, and the original function will become y equal to u power of 3. Okay, it means that now we have two functions. Okay, the function of u and the function of y. Okay, kita ada dua function sekarang. So we need to differentiate these two functions. Okay, to differentiate u with respect to x, so we will get du over dx, okay, which is 2x minus 5. Okay, this is the direct differentiation, kan? Okay, and then to differentiate this function, this is the function of y, okay, with respect to u, means that when we differentiate this function, we will get dy over du. Okay, so it will become 3u power of 2. Okay, this is the simple differentiation. So how to perform chain rule? Okay, we multiply these two differentiation. Okay, du over dx multiply with dy over du. Okay, multiply these two functions, these two differentiations. So dy over du multiply with du over dx. When we cancel out du over du and du, so we will get dy over dx, which is the same one, the same differentiation that we want to search for. Okay, dy over dx. Okay, make sure when you simplify this two differentiation, okay, kalau ada cancel out sana sini, make sure at the end you dah akan dapat differentiation of dy over dx. Okay, so when we multiply these two differentiation, okay, so meaning that 3u square multiply with 2x minus 5. Okay, multiply that, so kita akan dapat, okay, 3u, you need to change it back into our assumption just now. Okay, so our u is x squared minus 5x, so meaning that we will get x squared minus 5x square here. Okay, square turunkan kat sini lah. Okay, and then multiply with 2x minus 5. Okay, so this is the answer for dy over dx. Okay, actually this is the same one when you compare with the direct differentiation here. Okay, same kalau you all expand, okay, 2x minus 5 multiply with 2x minus 5 square multiply with 3, the answer will be the same with this one. Okay, when you fully expand this answer. Okay, so this is the answer when we get from expanding the original function. Okay, which is the working solution is a little bit long. Okay, because we need to expand or multiply this term 3 times. Okay, and another one is using chain rule. Okay, you can take a look at this solution. Okay, the solution ni tak panjang, okay, pendek je. We need to do some assumption and then differentiate each of the functions and then multiply. So this is the answer when we get from using chain rule lah. Okay, jawapan dia sama sebenarnya. Okay, let's take a look at another example. Okay, so basically the theorem of chain rule. Okay, chain rule, we need to find our u. okay, our u. So our the original function y will be in the variable of u. Okay, so kita darabkan macam tadi, du over dx multiply with dy over du. So kalau kita cancel out, akan dapat dy over dx. So this is the concept for chain rule. Okay, let's take a look at another example. Okay, in this example, the function we get is square root. Okay, square root of x power of 3 plus 2x. So we want to differentiate this function with using chain rule. Okay, look at the solution. First, we need to assume our u. Okay, basically, as I mentioned before, u is the simplest form in this function. So in this function, we can choose the terms in the third, okay, as our u. Okay, x cubed plus 2x. This is our u. Okay, so u equal to x cubed power 2x. And then our function, okay, the original function is fx, which is equal to u, y. Okay, y equals, okay, this function kita dah assume sebagai u, so we got square root u. Okay, so ni this second function, and this first function tadi. Okay, where we assume u equal to x cubed plus 2x, so the function will become square root u. And then square root u is equal to u power of half. Okay, and then we need to differentiate each of this function. So here is the function of u in terms of x. So when we differentiate this function, we will get du over dx. And then this one, this is the function of u, and we have the variable, this is the function of y, and we will get the variable of u. So when we differentiate this function, we will get dy over du. Okay, so this is the simple differentiation actually, where we when we differentiate x power of 2, x power of 3 plus 2x, we will get 3x square. Okay, 3x square plus 2. Then for this function, u power of half, okay, when we differentiate this function, we will get half u power of negative 1 over 2. Okay, negative half. So it will equals to 1 over 2 square u. Okay, and then we will apply the same step as the example before, where we need to multiply these two differentiation. Okay, du over dx multiply with dy over du. Okay, multiply these two differentiation, so we'll get 1 divided by 2 square u. Okay, multiply with 3x square plus 2. Then don't forget to change u back into the term of x. Okay, so simplify that, we will get 3x square plus 2, and then 2 here, and then square root u will become square root x cubed plus 2x. Okay, so this is the answer for differentiation of the original function using chain rule. Okay, so chain rule can also be used to solve questions involving trigo, exponent, and log function. Okay, so in the next subtopic, we'll look into how to apply chain rule to functions that got trigo, exponent, and log in that function. Okay, so kita terus pergi ke subtopik seterusnya, how to differentiate trigo function. Okay, this is page 37. Okay, here we have several theorems where when you want to differentiate sine function, okay, differentiate sine function, it will be cos function. Okay, cos function. But if you have the sine function other than x depan dia, let's say sine x square, sine 2x minus 5, Okay, sign yang selain X dekat depan dia. So let's say kita ada sign U. So it will we differentiate this function, it will become cos U, and then you need to multiply with du over dx. So actually this is the way when we apply chain rule, okay, to differentiate sine function. Okay, sine yang selain X depan dia. Okay. For example, we want to differentiate sine 3x plus 1. Okay, depan dia bukan x saja. Try sine 3x plus 1. Okay, so in this example, we want to use chain rule. So we will let our u equal the simplest form, which is 3x plus 1. Okay, dekat depan u, dekat depan sine ni. Okay, kita pilih depan sine semua. You all tak boleh pilih 3x saja. Kita kena pilih the whole in the bracket. Okay, u equals 3x plus 1. So we'll have the function of y equals sine u. Okay, so we have two functions here. Okay, from this one original functions, kita split into two functions. Okay, because we want to use chain rule. Okay, and then differentiate each of this function. When we differentiate this function, okay, this is the function of u. Okay, and we have the variable of x, meaning that we when we differentiate, we will have du over dx. Okay, and then this is the function of y, variable u, so we will have dy over du. Okay, so this is the simple differentiation. 3x plus 1 will differentiate it, we'll get 3. Okay, and sine u we will get cos u. Okay. Okay, then when we already differentiate these two, okay, and then we multiply du dx and dy over du. Okay, so du multiply with dx, okay, multiply it with dy over du. Okay, make sure when kita simplify du, okay, and du kita boleh cancel out, so dia akan jadi dy over dx. Okay, so it will become dy over dx. Okay, kalau kita cancel out du, so du over dx is 3. Okay, 3. Dy over du is cos u, so 3 cos u. Okay, so u change it back into 3x plus 1. So this is our final answer, 3 cos 3x plus 1. Okay. Okay, this is the concept for differentiation of sine. Okay, it will become sine x. Differentiate it, will become cos x. Second one is to differentiate cos x. Okay, to differentiate cos x, it will become negative sine x. Okay, so take a look at this example. We want to differentiate the term of cos. Okay, but not cos x, it is cos x squared plus minus 5. So we assume our u is in the bracket here. Okay, x squared minus 5. So when our u is here, so the original function will become y equals cos u. Okay, and then we differentiate each of this function. Okay, du over dx, it will become 2x. Differentiate this, it will become dy over du, it will become cos, differentiate with it will be negative. Okay, negative sine x, so negative sine u lah kat sini. Okay, so kita multiply these two differentiation. Okay, dy over du multiply with du over dx. Okay, as I mentioned before, make sure when you simplify these two differentiation, okay, du cancel out with du, we will get dy over dx. Okay, so our dy over du is negative sine u. multiply with du over dx, which is 2x. Okay, so kita simplify dia 2x sin u, kita tukar balik kepada yang ni lah. Okay, x square minus 5. So ini jawapan akhir kita. Okay, the third one is the concept for differentiation of tangent. Okay, tangent function. Okay, differentiate tangent x. Okay, it will become secant square x. Okay, differentiate tangent x, it will become secant square x. Okay, next, if we differentiate secant x, it will become secant x tangent x. And we differentiate cosecant x, we will get negative cosecant x cot x. And differentiate cot x, okay, we will get negative cosecant square x. Okay, all of this you need to remember in order to differentiate trigo function. Okay, the basic trigo function. Okay, so kita tengok another example here. Okay, this time we want to differentiate this function x cubed. Okay, multiply with cos x. Okay, these two functions is a two term. Okay, two term connected by multiplication. X kuasa 3 darab dengan cos x. So to differentiate this function, we need to use product rule, where our u is here and our v is here. Okay, so u is x cubed, v is cos x. So u prime 3x cubed and v prime is negative sin x. Okay, and then kita guna product rule lah. Okay, u v prime plus v u prime. Okay, so we will get this one. Okay, for the answer. And then another example is the function g here. Okay, tangent x divided by 1 minus cosecant x. So for this function, when we want to differentiate, we need to apply quotient rule. Okay, quotient rule sebab dia bahagi kan. This term bahagi dengan this term. So this term will become u. This term will become our v. So our u is tangent x and v is 1 minus cosecant x. So u prime equals secant square x and v prime equals, okay, 1 differentiate 1 is will become 0. Okay, and then negative here, and then cosecant x, differentiate cosecant x, will get negative cosecant x cot x. So negative, it will become positive cosecant x cot x. And then apply the quotient rule here. V u prime minus u v prime divided by v square. So just insert into the formula and simplify. So we'll get this answer. Okay, the next example is differentiate x sine 2x square minus 5. So this time we have two different function, which is x, okay, x and sine 2x square minus 5. It is connected by multiplication, so we need to perform product rule. So this is our u and this is our x. Okay, so our u is x, so u prime is equal to 1, and our v, here is v. Okay, our v is 2x. Sorry. Okay, here our u is x. Okay, so u prime is 1, and our v is sine 2x square minus 5. Okay, to get v prime, we need to differentiate sine 2x square minus 5. So to differentiate sine 2x square minus 5, we need to perform chain rule. Okay, where we assume u as 2x square minus 5. This is our u. Okay, ni sekarang ni kita nak differentiate ni v equal to sine 2x square minus 5. Okay, kita nak differentiate yang ni. Cara dia yang dekat sini. Okay, so we assume our u, yang u ni lain u yang ni for the product rule. Okay, this u is for the chain rule. Okay, so our u is 2x squared minus 5. So this function will become v equals sine u. Okay, v kat sini. Okay, our u is 2x squared minus 5 and v equal to sine u. Okay, kita perform the same step dekat chain rule yang kita belajar tadi. So we need to find dv over du and du over dx. Okay, so differentiate sine u. Okay, it will become cos u. And differentiate 2x squared minus 5, it will become 4x. Okay, and then to find v prime tadi kita nak cari v prime kan. So our v prime is dv over du multiply with du over dx. So akan jadi 4x cos u. So change u back into u kita apa tadi yang ni So akan jadi 4x cos 2x squared minus 5. So this is our v prime. So masuk kat sini lah. Okay, 4x cos 2x squared minus 5. Okay, and then barulah kita apply product rule. Okay, product rule which is uv prime plus vu prime. Kat sini u v prime plus v u prime. Okay, according to this yang ni. Okay, so masukkan and then simplify. Okay, next one is derivative of exponent and log function. Okay, now we proceed on how to differentiate exponent and log function. Okay, here we have some formulas here. Okay, which is for differentiation of exponential function. Okay, let's say we have exponent power of x. Okay, when we differentiate this function, it will be the same. Okay, exponent power of x. Okay, but if we have exponent power of other than x, okay, let's say exponent power of u, and then we differentiate it, it will become exponent power of u, and then we have to multiply with the differentiation of u. It means that we have to multiply with the differentiation of the exponent's power. Okay, I repeat, to differentiate exponent power of u, you write the same term, exponent power of u, and then multiply with the differentiation of u. Okay, let's take a look at some example here. Okay, before that, another formula, okay? Another formula for differentiation of ln x. Okay, ln x. So ln x, when we differentiate it, it will become 1 over x. Okay, if we have another term other than x, let's say ln u, okay, so it will become 1 over u, and then we have to multiply with the differentiation of u. Okay, so take a look at example 2.16 on page 40. Okay, okay, want to differentiate this function. This is the exponential function. Okay, so we can use a chain rule where we let u as the power of the exponent. Okay, so we let u, okay, as I mentioned before, we assume u as the simplest form. So the simplest form here is the power of the exponent. So our u is assume that u equals 2x squared. Therefore, we have y equals e power of u. Okay, exponent power of u. So we differentiate these two functions, where here if you differentiate, we will get du over dx, okay, equals 4x. Okay, and here we differentiate y, so it will become dy over du. Okay, so it is equal, when we differentiate exponential function, it will become the same. Okay, so here we have du over dx equals 4x and dy over du equals exponent power of u. Okay, and then what happened next, we need to multiply these two differentiation. Okay, so du over dx multiply with dy over du. Okay, so if we cancel out du, we will get dy over dx. So in order to get dy over dx, we want multiply this to differentiation. So our du over dx is 4x, and multiply with dy over du is exponential power of u. And then change back u into 2x squared. Okay, so we will get 4x exponent power of 2x squared. So that's the final answer. Okay. Another example here. Okay, we want to differentiate ln tangent x. Okay, ln tangent x. Here we apply chain rule, and we assume our u equals tangent x. Okay, this is our u, tangent x. So this expression will become y equals ln u. Okay, because tangent x is u, so y equals ln u. And then we differentiate each of this function. Okay, here we have du over dx equals secant square x, and dy over du equals 1 over u. Okay, then we multiply these two differentiation. Here we get dy over du. Okay, this one dy over du multiply with du over dx. Okay, make sure when we simplify this form, okay, cancel out du, we'll get dy over dx. Okay, so insert what we get, dy over du equal to 1 over u, and then multiply with secant square x. Okay, so here we get 1 over u. Okay, multiply with secant square x, and then substitute back u. Okay, according to our assumption. Okay, u equals to tangent x, so we will get secant square x divided by tangent x. Okay. Okay, so ini cara apply chain rule for the function of ln or exponent or a trigo function. Okay, to differentiate that. Okay, proceed with this next topic. Okay, implicit differentiation. I think the implicit differentiation is syllabus in week 6. Okay, so now we recap what we have learned earlier. Okay, first one we learn about the concept. Okay, concept of to use the chain rule. Okay, the first one is we need to choose what the assumption of u. Okay, what is our u? Okay, and then we multiply du over dx, and then dy over du. Okay, we have to differentiation, and then we multiply that to differentiation. Okay, so and then we substitute back u in term of x. Okay, so itu cara nak guna chain rule, and then kita boleh apply chain rule untuk soalan-soalan yang function dia complicated. Okay, complicated. Contohnya macam ni lah tadi. Okay, this one. Okay, so for this kind of function, we assume u to be the terms in the bracket. Okay, and then if the function is the trigo function, So usually we assume our u as the term in this bracket. Okay. If our function is in term of exponent, for example, okay, exponent like this, so we usually assume our u to be the power of the exponent. Okay, that's for the exponent. And then for ln, okay, usually for equation of ln, we assume our u is the terms in the bracket, okay, in the bracket in front of the ln. Okay. Okay, so that's all for the syllabus for this week. So we will continue this subtopic for week 6 next week. Okay, that's all. If you have any question, please feel free to PM me anytime on Telegram. Okay, Assalamualaikum warahmatullahi wabarakatuh.